Now, here is a very interesting question. So we have, which of the following is the density of nitrogen at STP? Now, we'll not only be solving this question, we'll be expanding beyond what the question is asking, so that when you see similar questions, you'll be able to what? You'll be able to attempt them. Now, let's start. First, the question is asking us to calculate density of nitrogen at standard temperature and pressure. So STP stands for standard temperature and pressure. And generally, when we say density, we know that density, usually represented with this symbol rho, is mass divided by volume. That is the formula for density. Now, what is standard temperature and pressure? Standard temperature and pressure. The standard temperature is approximately 273 Kelvin, or you say 0 degree Celsius, right? And the standard pressure is what? Is 1 atmosphere, or we say standard pressure is approximately 760 millimeter mercury. Okay, and in other units, standard pressure is also 1.01325 times 10 raised to the power 5 Pascal, or instead of writing Pascal, you could write it as 1.01325 times 10 raised to the power 5 Newton per meter squared, because 1 Newton per meter squared is what we call 1 Pascal. Also, your 10 raised to the power 5 Newton per meter squared is what we call bar. So I can write this as 1.01325 bar. So you should be aware of these various conversion within pressure. Now, also, what is the important point in this question? Nitrogen is a gas, of course, and from basic chemistry, you should be aware that 1 mole of a gas, 1 mole of a gas at standard temperature and pressure occupies 22.4 dm cube, 22.4 dm cube of volume. Okay, so this is what we call molar volume. So molar volume, okay, molar volume is equivalent to what? Is equivalent to, we say, 22.4 dm cube per mole. Okay, in some other cases, you could see it written as 22.4 liters per mole. So this is another very important point you should know, that 1 dm cube is equivalent to 1 liter. To solve this question is very easy, but my target here is that if you see a similar question around this topic, you should understand the various key terms that the question is in the question. So having explained this, so take note of all these key points. You can note them down. Now let's erase this. Now let's go to the question now. So some of the very important key points that we have noted is that 22.4 dm cube per mole. 22.4 dm cube per mole is our what? Is what we call the molar volume. It's what we call the what? The molar volume. So it's very important. You should note that. Now, at this STP, of course, the mass or the molar mass of nitrogen is 2 times 14, because nitrogen is M2. So 1 atomic mass of nitrogen is 14. So 2 times 14 will give us the molecular mass of nitrogen gas, which will give us 28 grams per mole. Right? Now what is density? So density at STP is nothing but the molar mass all over the molar volume. Molar molar volume. And the molar mass of nitrogen is 28 gram per mole divided by, while the molar volume at standard temperature and pressure is 22.4 dm cube. And remember that we said dm cube is exactly the same thing as liter. So from here, you can see the mole will eliminate. And if you divide 28 by 22.4, you should get 1.25 dm cube per 1.25 gram per, 1.25 grams per dm cube. And we say dm cube is the same thing as what? Liter. So we can say 1.25 grams per liter. And in this case, the correct option is option D. That is as easy as that. So see you in the next question.